Alright, hey guys. Sorry, yes, I am going live. I was a little bit delayed. I was in the middle of watching a show. I just had to finish the last season of The Flash. Uh, the ending of that show was pretty good. Left a lot of cliffhangers. I'm excited for the next one to come out. But anyway, let's get started with the live stream. Sorry about a little bit late. Let me fire up my lights. Sorry about that. Forgot to light them up. I think I gotta plug them in first. There we go, all good now. Almost there, guys. Then we'll get started. Okay, how is that? One more light, and we should be game. Good to go. Gotta plug in my stuff. Sorry, I've been camping. Alright, we're all good to go here. Not sure if you can see me. I actually probably can, but we're gonna get started with this video. First, let me check the comments. Haha. How could I work in such a neat and clean, organized environment? Someone asks. Whoever said this is always clean, neat, and organized? Right now, my bench is clean and neat and organized, but I just did that for this video. Typically, my bench is covered and can't even see the wood. It's typically not clean, neat, and organized. But anyway, let me get started to what the point is of this video and what I'm going to be doing, and what you guys can do too. So, a long time ago, I made a video for a channel called EEV Blog. And now what happened in this video is the guy who runs it lives in Australia, and he was going on vacation, and he asked for lots of YouTubers to make a video. Well, he asked for people to make videos and submit them to him to upload on his channel while he was on vacation. And I submitted a video, and it ended up on his channel. So I never posted the video about this device, and it was this small frequency counter. So a lot of you guys probably never watched that video, which is fine, because I don't think I really told anyone about it on my channel. But anyway, we're going to be taking a look at this frequency counter, because I haven't really touched it since I made that video. And we're going to be seeing if I can make it work again, and maybe even make it work better, which should be cool. And it's been so long, I almost forgot how this thing works or what everything did. So we're going to have to take a look at some of my old schematics and see how it works again. Let's get started. Oh, one more thing. If you guys want me to take a little detour anytime, just suggest something for me to build or ask a question, and I'll answer a question. And, yeah, let's get started. Alright, so first of all, we need to find my old schematics. So I've got my box of schematics, and we're going to need to look through these to find the schematic of this device that I built, my frequency counter. This is the frequency counter right here in the reel. It's got a bunch of different perf boards and a bunch of wires coming out of it. Let's take a look at my box. I think I can find it. I've got schematics here for all kinds of different things that I've built. It's got to be in here somewhere. Gotta find it. Oh, here it is. There we go. It's not exactly that much of a schematic, but it's the picture I used to make this video. And it's got a lot of important things on it that kind of explain how this device works. So basically, this is a frequency counter. And what a frequency counter is it's meant to time the exact number of... Wait. Okay. Let me explain what a frequency counter is to the person who just asked. I was about to explain it. Basically, what it is to count the exact number of pulses that happen in 1 second, to count the frequency of that. So, when you've got something pulsing or something oscillating at a certain frequency, it creates any number of waves, maybe square waves, maybe triangle waves, maybe any kind of other wave. And it's able to, yeah, certain oscilloscopes do that. Sometimes it's easier to have a device that can just straight out display the frequency on it. So there's a lot of different devices that put out different frequencies, and it's cool to measure them. Now you can use an oscilloscope to just straight out look at the frequency and use the time base of the lines in the oscilloscope to calculate out that frequency for yourself. Or my oscilloscope can you can find the frequency just by adjusting lines to go on the different peaks of the waveform. But sometimes something like this is pretty cool, and I wanted to make my own. Now you can use an Arduino to make one of these, but I figured it would be fun to build my own analog device. Now what happens is I'm using these chips called CD4026B chips. Basically, these are 7-segment display driver chips. And so you connect these up to a 7-segment display. And then you have a few different functions on this chip, and I'll explain how this chip works and how everything else functions. Now, forgive me, it's been a while since I've taken a look at this. I just got this out of storage. So you have a clock. You have a clock symbol on here, and one pulse to the clock pin will advance whatever number is on the display by 1. So let's say you had this display displaying 2. If you did one singular pulse on the clock pin, this display would go up 1 digit. So it would go from 2 to 3 or 3 to 4 or whatever there. And so you could just, if you keep pulsing this clock pin and the digits would keep advancing. You could pulse this clock pin as slow as you wanted at 1 hertz and it would advance it every second, or you could click this clock pin at 1 megahertz and it would advance it 1,000,000 times per second. You've also got a few other pins on here. You've got deck out, and every time this clock pin is pulsed 10 times, 1 pulse will come out of the deck out pin, and so that can be used to activate other displays. So I've got 3 chips on here and 3 different 7-segment displays, so they can each display. So what would happen is this one would start and it would count 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we'll go back to 0 and it would pulse out 1 pulse to the next chip, which would start counting on the second counter, and so on. Let's look at some of the other chips. You can see that up close. We then have the disable clock pin, and basically when that pin is enabled, it'll disable the clock, and the clock will stop turning on. It just won't read anything from the clock pin. We've also got the display enable pin. When the display enable pin is high, then the display will turn on and it will keep counting. If the display enable pin is low, it'll still count from the clock pin, but the displays will turn off. They'll be dark. You've also got reset. That's important. But other than that, I think that's just about all. Let's take a look at how this works. As you can see, I've got some old diagrams from a long time ago. So you've got the clock disable pulse. You've got the reset pulse. You've got the display enable pulse on here. So with clock disable, it's going to be pulsing 0.5 to 1 second. Sorry, it's taking me a little bit to remember how this device actually works. So what's basically going to happen is you're going to have the clock being pulsed at a certain frequency, and that's going to be advancing the digits for a period of 1 second. So I'm not sure exactly what this 0.5 to 1 second means right here, but it's going to be pulsing the clock for a period of time, and for that period of time the clock is going to be enabled and the display is going to be, oh, okay, I think I just realized this. So the display is going to be enabled and the clock disable is going to be enabled. So the clock is going to be disabled, so whatever is stuck on the clock is going to be stuck there, and the display is going to be enabled. and so it's going to be showing one thing for a certain period of time. Then as soon as that period of time is done, the clock is going to turn off and the reset pin is going to activate, which will reset anything on the display back to 0. And then it will have a period where the clock is not disabled and the display is disabled. And it's going to be this period of time where it's going to basically count all of the different clock pulses that are going to happen within that period of 1 second, which should give us an average frequency reading if it's a square wave. And what will happen is the clock disable will turn on, the display enable will turn on, and we will have a period of time where you can look at whatever is displayed, which will be the average frequency for that 1 second period. And then it will reset it and go on. So this 0.5 to 1 number right here is how long you want your display to be enabled for. That's pretty cool. Now let's take a look at this. So in the video that I made for Dave from EEV blog, I built this device and I hooked it up to an Arduino. So I had an Arduino right here, and the Arduino was the one giving these pulses to these 3 pins, so that way I could give all the timings exact. Now, in the period of time after I made this video, I did a few other interesting things where I tried making these 2 boards with 555 timers on them. And these 2 555 timer boards were there to generate these signals by themselves. Now this is a little bit tricky and it didn't always work. Now let me explain kind of how I set up these 555 timer boards. From what I can remember, it's been a few months since I worked on this. So I'm pretty sure I had this clock disable pin and the display enable pin connected together, because when the clock disabled, the display would enable. Just a second, I'm reading comments right now. Hi, Rachel McReynolds. How are you doing? Okay, sorry, I just read the comments. Anyway, I think I connected clock disabled and display enabled together. And I had reset separate. And I had the reset controlled by when the display enable pin went low, because I had the enable pin on the second 555 timer enabled, which means that these two are running together. I gotta kind of figure out what my whole mess of wiring does right here. So this wire, I know for sure, is the clock pin to the first counter, so that makes sense. I've obviously got my power and ground pins over here. Now I put an LED right here as a resistor, and I kind of forgot what that was for, but I remember the only way this thing would work is if that incandescent light was hooked up and turned on. I'm pretty sure that all these other 2 555 timer circuits can get their power from here. I think we have the power rails connected together. All the power rails are lined up. I'm not sure exactly why there is a wire coming from the positive power rail here, but I've got these 2 555 timer circuits all running. In fact, I'm not sure why there's a negative power rail coming out here. It must go somewhere. Well, anyway. This is really confusing. Let's see if we can sort out which wires are going in and going out of the circuit. So we've got this red wire, it doesn't go anywhere. I think it's just there to be there. We've got power wires, and we have one pulse coming out of this. And this pulse comes straight out, and it goes into this device. And let's see where it goes. It goes through a bunch of different things. And it goes to pin... goes to pin 15 on one of them. Let's see what pin 15 does. That goes to the reset pin. So this second 555 timer circuit is just going to be giving the reset pulses to the whole circuit right here. So that makes sense. Let's see about this second circuit. Oh, I forgot about this. What does this do? This is interesting. This is wire right here. It goes to a transistor. I think I have that transistor acting as a inverter. And that's coming from here. It's going into pin 8 of the 555 timer chip, and also an LED to ground through a button. What's pin 8 of the 555 timer chip? I forgot about that. I mean pin 4 of the 555 timer chip. If anyone wants to figure that out for me, I don't have my phone's doing the live stream. Figure out what pin 8 of the 555 timer chip is. I want to remember that one. I used to have that memorized or something. I guess I forgot. Alright, let's see what's next. Got the second chip. Oh. This wire goes... Pin 4 is reset? Okay. Okay. Pin 4 is reset. That means this button resets the 555 timer that's sending the reset pulse. So that pin resets the reset 555 timer. It's a little bit of a tongue twister. So I've got wires going everywhere here. It's a little bit complicated to understand, but it's funny someone commented this is how NASA was built. It's interesting looking at your own circuits that you built a few months ago to see how they work. So many wires going everywhere. So we got reset of here going to this button. And this button goes from here to here. Wait a second. You know what? Let's fire this thing up and see what it does. Might as well. I'm going to set this to 5 volts because that's logic level. This is a pretty filtered power supply. Let's see what happens. If it doesn't work, I'll turn up the voltage. Up. We're getting something. Well, it looks like it's working. It looks like this light blinks every other turn. And we're getting a 0, 0, 0 on the output. Let's put it in random and see what happens. Oh, gotta plug in my function generator. We're gonna see if we can make this work. This is very interesting. It just blinks and flashes a 0. Just hold up a second, my friends. I'll hook up my function generator. There we go, we got power. We're gonna figure out this circuit once and for all. Alright, just a second. Okay, so you said if my power supply is noisy, would that affect the camera itself? I don't think so. The power supply I don't think should be affecting anything. Let me turn off this light so you can see that better. So we're going to set this thing to... We're going to start it with a very low frequency. We're going to set it to like a square wave, 5 volts. Duty cycle 50%, frequency in hertz. Maybe we'll set it to a little more than 5 volts. And we'll connect that up to my device and see if anything happens. Oh, now I know where that ground is going. That ground is to connect your other part too. Okay, so we're getting a 0 out of 0. Let's crank up that frequency on here to like 5 hertz. We see that this light is flashing at the frequency supplied by my function generator. All my other lights are flashing correctly. You guys got a bunch of cool lights flashing. And then my display, which isn't working. Let's crank up that voltage a little more. It from what I remember, the voltage has to be kind of high in order to register on the function generator. Okay, well, something's happening. I have it set to 121 hertz, and we're getting random flashes of 0, 1, and 3. That's interesting. And 4, see, we're getting random flashes. That's strange. I have the voltage set to 7 volts, so it's obviously getting reading from that. It's just not working as well as I thought. Now let me see what happens when I unplug these lights. I kind of forgot what happens when you unplug these lights. Let's see. Nothing, it seems. Let me turn this off. An electronics breadboard from an actual breadboard. Good idea. Well, from what it seems, these lights aren't really doing much. What does this button do? Forgot about that. Let's press the little button I have on the board. See if that does a thing. Alright, so it's just flashing between 1, 3, and 4. Let me crank the frequency to like 341 kilohertz. We're getting a flash to 9. Let's see what happens if I crank this up to like 1 kilohertz or something. Oh, we're getting... Wow. We're actually getting numbers on here every other time. Let's see if I can focus in on that. So it's flashing between 156, 0, 0, 177, 16, 0, 0, 160, 0, 0. That's strange. Hope you can see that pretty good. Okay, let me adjust the, okay. That's weird. So, I'm guessing some of the timings aren't right on this 5x5 timer circuit. Because with the wrong timings, it's causing... I don't know. You know what? We saw the reset pin, so that means clock disable and display enable are in the same pulse. But I think the display enable is happening after the reset pulse. What do you guys think about this matter? Why is it doing such weird things? Let's crank this up to 10 kilohertz. And we see that this is going to 71. 293, 0. 300, so it's, I don't know. What do you guys think is causing this? This is working just fine when I have the Arduino controlling it, but no, there's no Arduino controlling it. I've just got analog circuitry controlling it, which is funny. So we've got clock disable and display enable. I'm pretty sure those are both controlled by this 555 timer chip. Because, as you can see, this light flashes and it stays on. Basically, the lights on each board are the outputs from each 555 timer. And so we've got... this chip, and this one is flashing on. And it stays on for a bit and then does a quick off pulse. And during that off pulse, it turns this one on. Now, I'm kind of thinking that off pulse is not very long. So that off pulse may be, in fact, when the clock is enabled and the display is disabled. And I think that fraction of a moment is a time period where it's reading the frequency. And it's low for some kind of reason. You know what? Let's adjust some of these potentiometers. Not sure exactly what they do, but I'm pretty sure it's to adjust the duty cycle. Because if you look down here, we have a diode across this one. We have a diode across this potentiometer. Yeah, it seems like these ones are to adjust duty cycle. So I'm going to adjust the duty cycle of this one and see what happens. Okay, wait. I'll show you this. I'll tilt this up. How about that so you can see it? Let me get something under it. It's at 10 kilohertz right now. Can you guys see this number very well? See, what I need is a piece of red cellophane. That's how alarm clocks work in order to see them pretty good. Let's adjust the duty cycle of this. Okay, I think I adjusted it way too far. Let's adjust it the other way. Okay. Okay, it's giving more time in between. Oh, how's that? Yeah, that makes sense. Here, so you can see that now. It's flashing random numbers, but the display is being off for longer, so it's taking longer to count. Let's crank it down to 341 hertz. Still flashing weird numbers. 1 kilohertz. 83, 55, 29, 100. Okay, let's fire up the oscilloscope. We're going to use this. I'm hooking up both probes. Oh, I forgot about one thing. The oscilloscope is sometimes stupid in the fact that it shares a ground with V++ of this thing. Okay, let's fire this up. First, let me grab my oscilloscope end probes. Lucky for me, the oscilloscope ground is common with the ground on here, so watch a quick trick. Oh yeah, watch a quick trick. If I connect the grounds together, barely works. So let's hook this up and see what we can get. Set this to both on my oscilloscope. I think, let me set these both to DC. We're going to set both probes to 5 volts so we can get a logic level signal. We'll set this to alternating. We'll connect one of these probes to the output of 1555 timer circuit. And so that output is probably going to go... my oscilloscope is a Tektronix 2232. Okay. We're going to be connecting channel 2 to the reset thing. So the reset is coming out from pin 3 and going here, I think. Nope. Pin 3's output is brown. So pin 3 goes here. Oh, now the triggering is wonky on here. Maybe the time base is wonky. Okay, this is just confusing. This oscilloscope is not as good as the digital scopes. So, in order to actually see the pulse, I have to have the scan rate turned off so fast. Let's just set it to channel 2. Well, there you see it's triggering. Oh, you did? Awesome. Nice job, Black Corvo. You know what? We're going to do a quick trick. And we're going to try to create these two signals on the function generator to drive this display. And then we will see if we can get it working without these two wonky 555 timer chips. So let me disconnect my oscilloscope. I'm probably going to get a better oscilloscope sometime soon. More digital. But, as you can see, we're still getting wonky results from that. It's like 22, 01, 0, 76, 53. Just spitting out random numbers. I mean, this thing may be better as a random number generator than a frequency counter. We got both lights dumping heat. We got oscilloscope signal from there. I'm going to disconnect that up. Let's see what will happen to these lights if I turn up the frequency of this one. Whoa, that's weird. Let's hook that back up to the frequency generator. Whoa, it's now counting. $420, $370. It's giving out random numbers. That 22, 15. Strange. This is the weirdest project right now. Let me crank up the frequency on this one. I'm pretty sure the reset pin just connected up to it. Let's see if we can speed up this circuit. We're getting a stable pulse around 590 here. 591, 591, 592, 581, 588, 571, 601, 582. It's relatively stable right now, despite the fact that this thing is running at 6 kilohertz. Probably can't see that. Let's see, if we adjust this to 5 kilohertz, will this move down to like 4 or something? No, really doesn't. It's weird. What happens if I pull out this fat electrolytic capacitor? Oof. Where was that at? Oh, dang it. Where did that go? That fat electrolytic capacitor, I think, is the timing capacitor for this whole circuit. Let's see if we can't shake things up a little bit and disconnect it. So this goes to the reset pin. I'm just going to pull that out. So basically this isn't resetting. It's just flashing. And now the reset pin isn't working. It's all wonky. It just overflows. That's why. That's weird. What happens if we disable the other one? I'm not sure where it's going to. I think it goes here. There we go. It's our second one to disable. So this white one, the white wire, is going somewhere important, probably. Maybe I don't think these ones can be floating. That's why. Let's see. We got this thing. Will probably start counting. We can do. We got reset is I think the blue one, because that goes. Yeah, reset is the green one. And reset, we can put that on ground, and hopefully that won't do anything. That'll ground out reset. And then for the other two, we can ground that one too. That should have started at counting, which it's not counting, obviously, for some reason. Display is enabled. Well, that's strange. Pin 10, display enable, which is pin 3, is, I don't know where that one's going. Display enable is going here, which is strange. Oh, I don't even know anymore. Interesting. So we've got the... This makes it so difficult. I'm just going to pull out these. So we got clock. That's the only good one. We've got clock disable, and that one's at pin 2 of the chip. So that's this yellow wire, this blue wire. This is clock disable for all of them. This blue wire is. Let's see. Let's go to the next one. We have reset for all of them. Reset is pin 15. Pin 15 goes to this yellow one. Pin reset is the green one. That's the only one that goes to it. Then we've got the final one, which is display enable. Obviously, the display is enabled. Display enables pin 3. So we got pin 3 of this one, orange, black, white. White is display enable. I think that should be all. Oh, no wonder it's not doing anything plugging into this strip of the breadboard. It's not connected to anything. What a joy. Let me get another breadboard. Alright, second breadboard time. We have clock disable. Pin 2. Clock disable. We have reset. And we have display enable. So we have these 3 pins. And now we'll connect these up to different power rails through the smaller breadboard to see what effect it has on the display. Right now it's being pulsed at 10 Hertz. So hopefully we should see it counting up and then not. Ugh. I'm just a web of wires down here. Where are you guys all from on here? Any interesting places? I got 15 viewers right now. Comment where you're from. That'll be cool for me to know. Something to separate from the monotony. Ooh, Canada? Brazil? Oh, cool. We got Brazilian and Canadian. Canadian, eh? Oklahoma? Wow. It must be late for Oklahoma. From Spain, too? Madrid, Spain? I got a question from the Brazilian and people from Spain. I know you guys probably speak Portuguese and Spanish, respectively. But how well do you guys understand my videos in the English that I speak? Oof. Seems late for you guys. Let's see. Clock disable. Almost there. Just need a few more wires. Well, that's cool that you guys are from everywhere. Awesome. Thanks so much, Black Corvo. It's cool that you can understand it all. Connect this up to positive. This up to ground. Alright, now we'll connect. This is clock disable to ground. We have reset to ground. Oh. And we have display enabled. Wow, what do you know, guys? We got it counting. How can you see it counting? Watch, let's crank it up. Crank up the speed at which it counts. Well, I mean, technically it works, but it doesn't really work. Right now it's counting, but we don't have that time period for it to count in a second and then freeze the clock. So this is cool, but it's not perfect yet. So we're going to hook this up so we can just see it counting with another 555 timer circuit. And we're going to see. I think I have a 555 timer circuit up here somewhere inside my little box of stuff. Just a second. I know I have something somewhere in here. Oh, there we go. Alright, we got this 555 timer circuit. I think it works. It's been so long since I used this thing. This is craziness. I don't even know which pin goes to which pin. We're gonna get this semi-working. See, right now, it's counting pretty fast. Like, really fast. It's because it's running at 4,440 hertz. Let's crank that down. What we're basically going to do is we're going to go in and set some things manually inside this circuit. And actually, we're going to be using this output. So pin 3 of this is going to be connected up instead of this. Just a second, you'll see what I'm doing. We're going to... Oh. We're going to connect up the output of this, pin 3 of this circuit. So as you can see, we've got a 555 timer counting that amount. Let's see if we can change that with changing this capacitor right there. And we can see if we can up that frequency significantly. So we've got this capacitor. I'm going to switch it out with a smaller electrolytic capacitor. Let's see, what value is that capacitor? I think it's like 10 microfarads, I think. So if I put a smaller capacitor in there, it's on the order of like not as many microfarads. It should work good. This is a 104 cap. I think the 104 series is like 10th, maybe 100th of a microfarad. Well, let's try that out. See how much faster it goes. Oh, we just like broke the display. Too much speed. Oh, there we go. We got it working again. Yeah, 1/10 of a microfarad. So then we get it counting up again. You see how it's going super quick. Let's see if we can adjust this speed. Oh yeah, we significantly sped it up. I turned the screwdriver the other way. Six. Oh. It's almost as if that potentiometer doesn't do anything. Well then, let's start setting a few values for this. We will set this one to 0 hertz. We're going to set channel 2, which is the one we're on. And that's going to be the reset pin, I think. We're going to set the reset pin to do a quick pulse every second. Maybe every 2 seconds. No. 0.5 hertz. So it's going to be doing a pulse every 2 seconds, I think. That should be good. And we're going to connect channel 2. Oh, first we're going to connect this device to ground. We're going to connect reset to reset. As you can see, it resets it at a certain interval. It counts to a certain number and then resets it. So as you can see, it gets to like 140 something and then it quits. But what we want it to do is we want it to freeze at that certain interval. So that's what we want to do. So what we can do is we can take the reset and we can set the duty cycle down way to like 10%. So that just pulses the reset pin just a little bit. And we can switch to channel 1. We can connect channel 1 up to these two same pins that are going from... Oh, that's interesting. Whoa, that's like a cool beat. Look at that. 154.2080. 154.280. 154.280. 150. Oh, now it's doing random stuff. Yeah, it's out of sync. So what we're going to try and do is if I change... It's 1 hertz right now, so this changed the duty cycle down a lot. Let's crank up the duty cycle. A lot, maybe? At a 90% duty cycle, that equals them out. 119.0. Well, at least we're getting a solid reading. We're getting a 119 and 0. Let's adjust that frequency, maybe. I'm adjusting the potentiometer over here. Let's adjust the potentiometer the other way. The way. This is weird. It seems like it's still controlling the clock speed. What in tarnation? The only output we got going here... This is weird. This whole device, I had this setup working before with an Arduino. Trying to do it with this makes it trickier, and I wanted to get this all analog. You know what, let's do a quick trick and mess up the phase angle a little bit. Well, with the phase angle off, that makes it slightly weirder. 180-degree phase angle off. Switches between 1.8 and 0. It oscillates there. I mean, I don't even know what frequency is being outputted on this thing. Let's see if we can draw out what's happening, because this is a little bit confusing. And it's even confusing me, too. Let's draw this out. I'll draw it out on this piece of paper that I drew something on. So, we've got, on one channel... Okay. Haha. A funny comment from pranking electronics teacher by putting an SMD Arduino and something like that. Okay, let's see. Let's draw a time base. So let's draw a time base of 2 seconds. So this is first second, second. Let's see. Let's look at our first signal. Our first signal on channel 1 is a 1 hertz signal. You know what? Let's not phase shift that one 180 degrees. Let's phase shift the next one, which is channel 2. Let's phase shift that one 180 degrees. we're still getting the same result. On the first one, we have 2 seconds. And so, let's see what the duty cycle is 10 seconds. So this one, no, let's extend our time base a little more. So that's our time base with 4 seconds. And since this resets every 2 seconds, we're going to see a quick reset pulse. And that reset pulse is not going to do anything until the next second happens. And so this is the reset pulse. So then we got our 2 reset pulses. Now let's switch to our other one. That was a 10% duty cycle. And then we're going to got a 1 hertz pulse and a 90% duty cycle. At 180 degrees phase shifted. Here's where we get complicated. We're going to have it's going to be pulsing once every second. And so the pulse would start by being 90. It would start by being 90% on, and then 10% off starting here. But because we phase shifted it, this is going to be the pulse that turns everything on and off. It's going to be scooted This is a lot easier on Arduino because I could just time everything in milliseconds. We're going to see the phase shift 180 degrees. What would this look like with an 180 degrees phase shift on it? I'm just thinking. Sorry, I'm tired right now. I think I'd have to do a 90 degrees phase shift on there. Let's set that up. The 90 degrees phase shift, it looks something like that. I think the 180 degrees phase shift looks better. Not the best, though. Oh, God. That's the reset pulse. Let's crank that down. What the heck? This is so weird. I wonder how many... Oh, my phone battery is about to die. Oh, this is a joy trying to get working. It's always like this. I know I have that Arduino somewhere. There's an Arduino here. As you can see, I've written down the pins too. The Arduino puts out the exact amount of pulses that I need to. So these are the pulses that it's supposed to happen. We've got clock disable. That's going to be on for... It's going to disable the clock for 1 second. And it's going to enable the display for that 1 second. Well, actually what it should do is the clock should be disabled, which should be high. And then for a brief moment, the reset should start. And that reset pulse will reset the clock. And the display probably shouldn't be enabled when that happens. Should disable the display, then reset the clock. And in this period of time between here and here, between the falling edge of the reset pulse and the rising edge of the second clock, of the clock disable pulse, should be exactly 1 second. Exactly 1 second. And we have that display, and then the rising edge should be the same. So I'm thinking this should be fine at being the same. I may just have to fine-tune the phase shift and stuff. So that way we can keep it blinking the same number. So if we have 1 second, so we want it to have a 1 second pulse here, a 1 second off pulse here. So theoretically that should be a 50% duty cycle of 1 hertz. So 1 second on, 1 second off. And so theoretically that should be what we need for there. And then for the second channel, we need a duty cycle of like 8. So it does a quick reset. And we can fine tune it with, I think, the phase angle. Oh, you know what I just realized? Something wonky with this. Forgot to do the offsets. If we got the voltage as 5 volts, it's only, we need to have 100% offset in order for this to work correctly. And so we want to switch to channel 2, have 100% offset. That should keep things down here working more smoothly. Now let me adjust the phase angle of channel 2 until I can get it. Nope. Okay, that's the 180 degrees phase angle. And it's looking worse than it did before. Alright, good night. Well, okay. Someone said it would be easier to match the pulses using an oscilloscope. Yes, it would be easier to match those pulses. The only issue with that is my oscilloscope, if you crank down the time base too low, then this is what it looks like. It just looks like a dot pointing across the screen like that. And so we'll see the dot rise. I mean, it's an old oscilloscope, so you can't really blame it for this. I mean, okay, I got a question. So when I want to make my oscilloscope run at a very low speed, a low time base, it looks something like this. I've seen in videos of the digital oscilloscope, how they can have it and it's just one constant graph, and it shows where the pulses are, and it refreshes. But all I get is this. So if I raise the voltage, the little dot will rise, and it will move along. And this is when the time constant is 0.5 seconds. So you can see each of these little lines is 0.5 seconds. So that's 0.5 seconds for it going across here. can I get it so that way it shows? Oh, wow. Yeah, this is a digital oscilloscope. So someone mentioned there's a buffer, Black Corvo. How would I get that buffer to be put in here? I know I can do the store, and that kind of makes a buffer, but I don't think it works that well. So if I pop channel 1, a quick 5 volt, I guess you can see a 5 volt pulse there. That's wonky. That is wonky. Oh, wait. You can kind of see it. Sorry about it being blinky. It's not blinky for me. It's just something with the sync rate is not matched up correctly. If I hook this up to this one, maybe we'll get it right. Oh. That's strange. Maybe each of these channels works independently of another, and I have to connect the... Why am I getting a sine wave right here? Whereas on this one, I'm getting... Oh, it's because it's AC. And it's probably... What the heck? Look at this. This one is actually working in the buffer for the oscilloscope. Looks nice. Whereas this one, it just looks like a sine wave. Wait a second. I know my problem. Oh, look at this. Want to see a reason behind my problem? Sine wave. My goodness. Look at that. Forgot to change it to a square wave on the second channel. Wow. That would have been nice to know before. That explains things. Now I bet if I change the phase angle... something resembling something. Yep, the oscilloscope saves the day again. Now we can actually connect the oscilloscope up and see how things are working. Well, good night. I'm losing people, but that's fine. I understand it's late for people. Hi. You want my whole lab? Come get it. So there we go. We've got the pulses on the oscilloscope screen, if you can see. Now let's switch this into both mode. Really hope this works. Alt. Ugh. Ooh. That buffer is looking wonky. Let's see if we can connect her up. Oof. Things are looking crazy here. It's connected up to this connector. That's weird. Look at this. Can someone explain this to me? Look at that, $50. Why is this doing that? Something strange is happening there. So you got this pulse, and it's like... Sorry if you can't see that, but we've got this pulse right here, and we got another pulse. The quicker pulse. Oh, what's happening here? Why is it many pulses? That makes sense. It's just noise. Okay, we should get that matched up. Hopefully now. Yeah, that's strange. I don't know why the circuit is resonating like that. I don't see a reason why it should be. It almost looks like my function generator is making noise on there. Which is weird, because it shouldn't be doing that. Let me set both of my function generators to the same thing. So we got offset 100%, amplitude, 7 volts. See if the amplitude on my other one is the same amplitude. Let's get that up to 7 volts. Still nothing. Oh, my battery's low, 21%. I've got 21% battery left to finish this video, guys. Okay, let me just disconnect my function generator from the circuit in that specific one. I think that is channel 1. Let's see. Nope. That is channel 2. It's being stupid. So channel 2 goes to here. Oh! Now I know why. I was connecting it to the wrong probe. I was connecting it to ground. Well, shows how tired I am. It's late here in California, too. We're still getting that weird resonating effect, but it's slightly less bad. Oh. Is it even working now? Well, it was working, and now it's not. Channel 2 is not alive. Okay, we've got channel 2 working. We still got a bunch of noise on it, though. We got them exactly the same. %, duty cycle. As you can see, they're both the same. Let me adjust the voltage of the second channel. Oh, there we go. We got them looking alike. That's nice. Okay, we got both of them looking exactly the same. That's perfect. Now we can adjust the phase angle to 90 degrees. And you can see that that happens, spikes just right after that spikes. So let's see if we can adjust this picture to look like here. And don't be mad if my phone dies during this live stream. So we're going to set the phase angle offset to 0. I'm pretty sure that channel 1 is controlling Okay, channel 2 has got reset covered on here. So let's adjust. The reset pulse is fine. So let's adjust channel 1. See what we can get for here. I can't get that. Let's adjust this up. Okay, that's 1 now. And we should be putting out duty cycle more than 8. Actually, I think we need to go to 2 hertz. Let's look at the oscilloscope screen. Got something on there. Got a wonky number reading. Well, that works at least. Let's adjust the duty cycle of the second one. So now I just have a small reset pulse on there. And I think we have too many reset pulses. Okay, so we got 1 hertz on both of them. You know what? I'm too tired to think. Sorry, guys. Tesla coil guitar amp, that would be cool. I'll make this work on the Arduino, and then we'll look at the Arduino output on the oscilloscope, and then try to sync that to this. Thanks for the suggestions, guys, but I'm going to probably go to sleep. I mean, at least we got the oscilloscope working somewhat. Scrolling. Cool. Alright, guys. It's 10 o'clock here, and I'm tired. So, I'm not thinking straight, and so probably not building the circuit to the best of my abilities. So, I'll probably revisit this topic in another video or a live stream sometime soon. So I still want to get this working all analog, so that way I could build a final product that's an analog frequency counter. That would be pretty cool, just using these special kind of CD4026 driver circuits. That would be pretty cool. I may need a buffer or something. But, at least we got the oscilloscope working and I got some stuff figured out. Hopefully you guys learned some interesting stuff about how these frequency counters work, or at least the one that I wanted to make. I'll put a link in the description to the video that I posted on EEV Blogs channel. That should be cool. That one got a lot of negative comments, I think. Kind of weird. But anyway, I'm grateful for Dave for putting my original video about this on his channel. In that video, I actually had it hooked up to an Arduino and I made it work. In this one, I was trying to revisit it and make it work with some 5x5 timer chips, which are not exactly as accurate as they can be. But my phone's probably going to die in 2 seconds anyway. It's pretty low on power. So, with that, thank you for watching, and stay tuned for my next video. Also, thanks for all the comments. I really enjoyed reading all your comments in this video. That was pretty cool. Learning guys from Brazil and Spain, Canada, and Oklahoma is all pretty cool. See you later, guys.